Hi everyone, in this lecture I will just be covering chapter 2, which goes over sources of information. So when we're looking at different ideas or theories or hypotheses, whatever it may be in psychology, there's a lot of different places we can get our information. And obviously some of those sources are going to be better than others. So a lot of the stuff in this chapter is kind of intuitive, things that you probably, have thought about before or maybe heard of before, but maybe don't know the term or what it's, called. So everything I think is, kind of just makes sense. You might just have to learn terms for certain things. So on Educat, there are those flashcards for each chapter. So for this chapter, making sure you get those terms down and understand what those, each mean, the differences, you should be good. Okay. So research versus experience. So these are two different ways we can get information, right? So our personal experience. So, an example, you go to tanning beds all the time. So your personal experience, you've never gotten cancer and you've been going to tanning beds for 10 years. So your personal experience information is that, the tanning beds don't cause cancer, right? Because you have been doing it, you've experienced it and never have had that outcome. Whereas research would tell you otherwise, right? Exposing yourself to those UV rays does indeed increase the risk of cancer. Okay, another example is this tape. I forget what it's called. But there's research on the tape that, do controlled studies to figure out how effective this is at whatever it's supposed to be doing compared to your personal experiences when you use the tape. Maybe every time you put that tape on, your knee feels better. Or maybe you use that tape and you don't notice a difference. So the information you're getting from your personal experience might not be, the same as what you would get from research. And then one last example is personal experience of if you are angry, mad at someone, or just really frustrated, whatever. If you hit something, maybe you throw your phone against the wall, maybe you go type out a long status on Facebook and vent about it. Your personal experiences, that makes you feel better, but maybe that is not necessarily the case. And we will look at a study and lecture today that does look at the efficacy of venting that anger as, punching something to get rid of that anger, how effective that really is, because there's a common misconception that that's a good thing to do. Okay, but research versus experience. So obviously, those are both ways to get information. But as you probably should already know, research obviously is going to be a better way to get information for a number of reasons. I'm gonna go more in depth in these all in a second. But just, to start, experience has no comparison group. Experience is confounded. Research is just better than experience, which is kind of just accumulation of these guys. And then research is probabilistic too, which we'll talk about what all of these mean in the next few slides. Okay, so start with experience has no comparison group. Okay, so one of the main reasons why getting information from experience, is such a problem is that there's no comparison group. Okay, so if you use that tape on your knee and it feels better, like, that's great. Maybe that works for you that one time. But what if you wouldn't have used the tape? Perhaps your knee would have just gotten better anyways. Or if you punch something because you're angry and you feel better after you punch something, maybe it's just if you didn't punch something, you would have felt better too, right? Since it's our own personal experience and there's only one of us and we're basing it off of, just what we've seen, it's impossible to have a comparison group. And even if you try to wear, the tape on your knee one time and then the next time your knee hurts, you wear tape on your knee, the injury is not the same exact both times. So perhaps, again, what you're looking at, it's not a true comparison. Same with the punching thing. If you're angry one time and punch something, the next time you're angry, you try not to punch something and see if you feel better. Maybe what made you angry is different both times. So releasing that anger or feeling better is a different process for both of those, right? So if we're basing everything off of our own personal experience, it's very, very difficult to have comparison groups, okay? And a comparison group, I've kind of already explained it, but is just something that allows us to compare what would occur both with and without whatever it is that like interests us, okay? So example is the punching bag, right? So maybe you punched it, you feel better, but what if you wouldn't have punched it? You might have felt better too, right? Um, so we need a comparison group to really know for sure that that information, what we think is happening, is actually happening due to whatever it is that we think is causing it. Okay, so for like the punching bag, feeling better, we don't know for sure if we don't have a comparison group, if the punching bag is actually causing you to feel better, or if it's something else, or you just feel better no matter what. Okay, and your book is an example from the 1700s. There was a Dr. Benjamin Rush. He was a famous doctor at the time. I don't know, during the yellow plague or yellow fever. I don't know, some sort of plague back in the 1700s. And back then, obviously, medicine was not as advanced. And their treatment for the plague was to remove blood. So they would um, put a needle in your arm and just drain up to 100 ounces of blood over the course of a week, which is a lot of blood. And nowadays we know you should not do that. Even if you're sick, especially if you're sick, you need those white blood cells to fight off infections and whatever. But back then, they did this. Maybe they did it one time and the person got better. They said, "Oh, this works." And then they continued to do it and just kept doing it then for any sickness that happened. Whatever people came to them, had a headache, fever, whatever it was, just started draining people's blood, and never came up with a comparison group, which obviously is a problem, right? But they assumed just because they would drain the blood that if one person got better, if they saw a few people get better, then the blood draining must be what's causing that. And people died. Obviously, if you're draining that much blood, people are gonna die. But the doctors just said, "Oh, well, that's probably because they were just too sick and we couldn't drain enough blood to help them," which obviously you should know is wrong. Luckily nowadays, we have control groups, comparison groups. So if it was back in the 1700s and we were doing this, we'd want to drain some people who are sick and then have people who are sick as well and not have them drained to see if it's actually the draining of the blood causes a higher percentage of recovery than not. Okay, and this is all intuitive, and you took the statistics class last semester. But you should know that the percentage recovered is based on like what you're looking at, right? So if you have 20 people, 100 people blood total, 20 recovered, 80 died. It's a 20% recovery rate. Okay, 50 people bled, 10 people recover, 40 people die. That's also 20%, right? So even though in this case more people died, 80 people died, this one only 40 people died, what we are really interested in looking at in science is the percentage, right? We're not just looking at a number, we have to compare it to the other groups. And again, your book goes through this and it's kind of self-explanatory, but if you just change one number, it's going to dramatically affect your percentage rates, right? So in the second example, again, 10 people recover, same as this top example, but instead of 40 dying, only one dies, your recovery rate's going to increase because 11 people total, 10 recovered, so you have a 91% recovery. If you change it and you have the people die, a lot more people die, so 490 people die and only 10 recover, again, you're going to have a very different recovery rate, only 2%. So that's all kind of self-explanatory. I'm not really worried about like statistics and these percentages and stuff for this class. But it just shows you that these comparison groups are really important, because if we wouldn't have counted, how many people died and looked at the rates, we might think, if every time 10 people recover, then it's working, if we're just ignoring the people that die, right? So, I mean, that's, I think, self-explanatory in a 200 level college class, but if not, there you have it. Okay, so obviously we're going to need comparison groups. It's really important to have the comparison groups, so that we know, again, if that treatment is actually effective or not. Okay, so that's why research is better than our experience, because we can control these things. And another reason why research is better is because experience can be confounded. Okay, in the real world, there are several possible explanations for an outcome. The alternative explanations are called confounds. Okay, so one example, a study in the newspaper discusses the positive effects of exercise in older adults and their cognitive function. So they had older adults, they had a experimental setup where they had one group attend an exercise class and the other was told not to exercise and just stayed home, did whatever, didn't exercise at all, and then they measured the cognitive function. And they saw that the group that went to the exercise class had an increase in cognitive function. So it must be the exercise increases cognitive function. But there are confounds in this study. Okay, so normally in class we'd discuss this, but possible confounds. If you have older adults going to a group exercise class, that means there's other older adults there, right? So maybe it's not necessarily the exercising, but it's the social interactions with other older adults. If they're staying home by themselves all day, maybe they're not having any social interaction, which can decrease cognitive functioning. Perhaps it's, in the classes, not necessarily the exercise, but having to follow the instructor's directions, right? If there's someone leading the group saying, okay, squat, do this, do this, do this, following those directions and practicing, taking in information and, doing what you're told, maybe that's helping cognitive functioning, right? So in this experimental setup, there's a lot of possible confounds or other explanations for why, that one group had such a big increase in cognitive function. So that's what confounds are. An experience, just by its nature, is confounded. Because again, if you're just basing what you know off of your everyday life, there's a lot of other stuff going on. You're not controlling for other variables when, you're experiencing these things. So again, going back to that punching bag example, maybe punching the bag makes you feel better because it's just physical activity, not necessarily like taking your anger out on someone, right? Because that's the idea. You punch someone's face, whatever makes you feel better. But maybe it's just a physical exercise. Maybe it's something to take your mind off of why you're angry in the first place. Maybe doing a puzzle or some other, thing that requires concentration. Maybe that would make you feel better. Okay. There's a lot of confounds in everyday life when we're just basing stuff on experience that we can't account for. Okay. So that's why research is better if it's set up properly, because research can control for these confounds. Obviously, this study did a poor job of that, but ideally, when you're setting up a study, you would set it up in such a way that you're minimizing extra variables, taking into account all things, right? So you have a perfect experimental setup. And even if you can't do it in a single experiment, you can do multiple experiments and try to see if different things are affecting it. So if that could be a confound or not. Later on in the semester, we'll get more into this thing. Okay. So in general, research obviously is going to be better than experience because we can control for confounds. And we can also make sure that we have comparison groups or control groups, making sure that, what's happening is actually due to what we think is causing it to happen. Okay. So an example that your book gives of this is on that whole punching bag, getting rid of anger. thing. But Bushman in 2002 actually did a study on this to figure out, the truth, if it was actually beneficial to release anger, punching a bag, think about someone's face that you're mad at or not. So what they did is they had a group of 600 undergraduate students, and they had a confidant, which was a Confederate, which was a guy who was named Steve. But Steve was a Confederate, so he knew what was going on in the study, so he was part of it, but the participants didn't know that. So for each of the 600 undergraduate students, they were told to write an essay, and then they turned these in, and then Steve, again, the Confederate, he read the essays and then basically just talked shit about them, saying they're the worst essays he's ever read. He made really rude comments to each of the students. And in one of Bushman's previous studies that he did, they did something similar, and they knew, scientifically proven or supported at least, that this would cause anger in the students. So they knew that was a good way to evoke anger. So that's what they did for each of the 600 students. After they all were angry now, they were divided into 3 groups. So one group was just told to sit quietly. The next group was told to go and punch a punching bag, but just for exercise. Just punch this bag. We're doing this exercise experiment next, blah, blah, blah. And the third group was told to punch the bag and imagine Steve's face on it. So that guy that just said all the nasty things about your essay. Imagine, I know you're mad. You got to be mad at him. So punch the bag. Think about Steve while you're punching it. It's good, do that. And then afterwards, there was another part of the study where the undergraduate students then could shock Steve. They were given an opportunity. It was like a game. Steve got a question wrong, whatever, he would get shocked. Okay, Steve wasn't actually getting shocked, but the students thought they were shocking him. And they measured the strength and the duration of the shock as a way to measure the anger of the students. Okay, so group 1 that was just told to sit quietly had significantly less than average shock strength and time. So they shocked Steve less than average, less than just a normal person. Didn't shock Steve. If they punched the bag for exercise, it was just about average, right? And then those who punched the punching bag while thinking about Steve's face were way more likely to shock Steve, to give him stronger shocks, and to give him longer shocks. So it seems, based on this data, that punching Steve's face, and this is called catharsis, which is, I have the definition, the process of releasing and thereby providing relief from strong or repressed emotions. So that's the idea of punching something, or it provides you your release. So seeing if that's actually, beneficial in releasing anger. And they found that it actually made people more angry and more mad at Steve compared to people who just sat quietly and had a chance to just process their feelings, right? So it might seem logical that punching something gets, rid of the anger, you'll feel better. But in reality, when you do a study, you control for all the confounds, you make sure that all the groups have equal opportunities. Are they all angry? Blah, blah, blah. You see that that's not actually the case. Which just proves that research, obviously, we already know, but it's better than experience because we can control for all of these different things. Okay? But even so, research is probabilistic, which just means findings are not expected to explain all of the cases all of the time. Okay, so if you're basing your knowledge on experience, you are trying to buy a new car or something, and you talk to your cousin who owns, I think your book has talked about a Honda Fit, whatever that is. If your cousin owns that, you talk to your cousin says, this car is the shittiest car I've ever had. I hate this car. It always breaks down. Blah, blah, blah. Gets terrible gas mileage. I'm not comfortable. The seat, the steering wheel is weird. gives you all these reasons they don't like that car, unreliable, whatever. But if you look at data, consumer report data, which goes through and gets information from a bunch of consumers on all the different cars, they say that that Honda Fit is a very reliable car, right? So even though your cousin, whoever your cousin is, has a different opinion, that doesn't necessarily mean that that research is wrong, okay, right? If you're doing research, obviously there's going to be outliers. Maybe for someone, punching that bag does help them relieve their anger, but in most cases, in the majority of cases, research findings, show otherwise. So research isn't going to explain everything all the time. Okay, it's probabilistic. Even though most Honda Fit owners love their car, think it's reliable, occasionally there's going to be ones that break down more often, right? So your cousin, he's not lying, but in most cases, it's a reliable car. Maybe for some reason, it's not reliable for your cousin, okay? So research is probabilistic. So you cannot expect it to explain everything all of the time. All right. Some more reasons why intuition is biased. So basing your beliefs on your own experience or your intuition or thought, why that's an issue, is because our intuition can be biased. So these are all examples that we are going to talk about in the next few slides, but it's very easy to be swayed by a good story, which is biased, right? We hear something and say, oh yeah, that makes sense. Someone explained it really well or shows you something and it just makes sense, so you believe it, right? We shouldn't do that, really. I mean, it's hard not to, obviously. But if we're basing our information on reliable sources, we don't want to be easily swayed by someone telling us one thing, right? We can be persuaded by what easily comes to mind. And we'll talk about this as the availability heuristic. We fail to think about what we can't see. That's the present bias. We focus on the evidence that we like the best. That's the confirmation bias. And oftentimes we're biased about being biased, which is the bias blind spot. Okay, so all these have their own slide in a second. But this guy in the computer, I trust the site to tell the truth. And it says, you're right, and everyone else is an idiot, right? So we like information that supports what we think. We like information that just makes sense. If we see something often, we're likely to think that that's, the way it is, because we haven't seen anything else. So there's a lot of bias just based on our own experience, where we grew up, what we saw, how we were raised, right? All those things affect the way we think and the way we think about the world around us. So the first thing was being swayed by a good story. I don't know if this is going to work here, but an example of this is infomercials. They do a real good job of showing that these tools work really well, and it makes people want to buy them. So this one, for example, if it works, I don't think it's going to play when I'm recording. But it's the Clever Cutter. You can look it up. It looks really cool. It's this little knife, and the bottom is a cutting board, but it's like scissors. So you can just snip, and it snips the carrot right into the bowl. You don't need a cutting board. It's awesome. Right? And if we were shown something that's a good story, makes sense, we'll say that is a good product. Even though we've never tried it, we don't know if it's a good product. Maybe no research has been done on the product and there's not enough force or whatever to actually cut the carrot. Or if you put the carrot too close to here, it doesn't work very well. There's one spot. Maybe this breaks all the time because this lady's the only lady that's ever used it. So we don't know for sure if this actually works, but if we're shown something that makes it look good, we're very easily swayed, right? And that's just being swayed by a good story. So again, that punching things makes you feel better. That kind of just makes sense, right? And that all started actually back in the day, Sigmund Freud. A lot of his science was just based off of things that we knew because we didn't know much about the human body. So his idea, he's the one that came up with the idea of, letting things out makes you feel better, because he compared humans to a steam engine. And with a steam engine, if you build up too much steam in the engine and don't release it, it's very bad for the engine. So he thought that humans were the same way. If we have too many thoughts going on or keep everything bottled in, it's bad for us, because, like the engine, too much pressure will build up and it'll damage our cells, right? And it's easy to believe that, especially back in the day, because it's a metaphor. It just makes sense, right? Freud told a really good story. Everyone believed him. Um, and so everyone was persuaded that, oh, yeah, that makes sense. That must be true. So there's a lot of examples of this kind of thing, and a lot of things that, have been thought were correct for so long that it just makes sense, right? It's like intuitive, but might not necessarily be true. Okay. Your book has a bunch more examples, so read through that too if you want some more examples of each of these. Okay. Oops, did I skip one? Oops, no. Okay. The next one is availability heuristic, which is things that come to mind easily are more available to the memory and can guide and bias our thinking. So this is true of memories that are recent or vivid or more vivid, excuse me. So this is just being persuaded about what comes easily to mind. So an example of this, if you look at this picture, what M&Ms pops out the most? Maybe yellow, if you think there's the most yellow there. But really, there's more blue. But the blue blends in with the background. So that's kind of a way to think about this, is the things that blend in that you don't really see don't really matter, but things that are popping out at you, those are the things that you're going to notice. So, for example, shark attacks. I feel like everyone thinks shark attacks are super prevalent. That's because the news likes to report on shark attacks, right? So you're constantly seeing shark attacks on the news, posted everywhere. People warn you, oh, that's really dangerous. But the likelihood of being killed by a shark is 1 in 3.7 million. Dying in a bathtub is 1 in 800,000. Right? So you're way more likely to die in your bathtub at home than to die in the ocean due to a shark. But no one reports on dying in a bathtub at home as often. So things that come easily to mind, things that are recent in our memory, really affect how we view things. Okay. Another example of this, quicksand. When I was a kid, I thought quicksand was gonna be much bigger problem than it is. And that's because I feel like people always talked about quicksand. So if you hear something often, in your mind, it becomes, more important, or you think it's true just because you hear it all the time, when that's not necessarily the case. Okay, so that's the availability heuristic. Things that are available or easily come to your mind will persuade the way you think. Okay. Next one is the present bias. So for this, we notice what is present and fail to look for absences. So we don't ever look for negative information. So like the bloodletting example, they looked at the treatment, giving the treatment, saw that it worked, and that was enough. But they didn't look at when they didn't give the treatment, who recovered when they didn't drain people of all their blood, or when they gave the treatment, when it didn't work. Right? So when we're looking at information, we need to not only look at when things are present, when it's there and it's working, but also when things aren't there and that's happening. This is hard to explain. So another example, every time you see a bunch of red cars, they're speeding, so you think, oh, every red car must speed. But you're more likely to notice the red car because it's red, and you're more likely to notice a car when it's speeding. So you notice a lot of speeding red cars, but there's some red cars that you don't see, and they're not speeding. There's other color cars that you don't see that are speeding, right? So you're only focusing on what you see when it's present, red and speeding. not red speeding or red and not speeding. Okay, so this one is kind of a little bit more difficult to explain. But read through this in your textbook. It gives examples. But yeah, present bias. Confirmation bias is the next one. This is a tendency to look at only information that agrees with what we already believe. So we seek out information unknowingly a lot of the time that supports our beliefs already. And this is often called cherry picking. So we're taking the information that we take in, seeking and accepting only evidence that supports what we already think. Okay, so this cartoon kind of shows us. I've heard rhetoric from both sides. Time to do my own research and find the real truth. And they googie. Literally the first link that agrees with what you already believe, and jackpot, right? So you are trying to be an informed person, but maybe when you're doing your research, you're only looking at sites or articles that are supporting what you believe. You're only watching news stations that support what you think already. So you're not getting the full picture. And this is just kind of reiterating or reinforcing is a better word, reinforcing your beliefs that you already have, and not causing you to question anything, which is never a good thing. And people do that. So an example of this too from your book, they had participants take an IQ test, and they were just told their IQ was high or low. And then there was articles in like a waiting room afterwards with magazine articles about IQ tests. So it said, either the article said, oh, IQ tests are a really good way to measure intelligence. Here's the reason why. Or there was articles that said IQ tests don't actually measure intelligence. They're junk, blah, blah, blah. And the people who were told their IQ test was poor, they were more likely to be reading the articles that were about why IQ tests don't work. The people who were told their IQ test was good were more likely to be reading the articles about how accurate IQ tests are. Right? So based on what we're told, what we think, we're going to seek out information that confirms that, and makes us feel better about ourselves, right? So that's the confirmation bias, looking at information that agrees with what we already believe. And then the last bias we're going to talk about is the bias blind spot, which is also a little bit confusing, but not really. It's just that everyone doesn't think that they're biased, basically, right? We know about these biases. It makes sense that people want to seek out information that supports what they already believe. It makes sense that, you're more likely to pay attention to what easily comes to mind. But we know that that's the case, but we think that we're not like that, right? We say, well, when I'm looking at information, I look at everything, when a lot of times we're really not. And it's hard to self-reflect because we can't see ourselves from an outside view, right? So most people have a bias blind spot, right? So we think we're unlikely to fall prey to the other biases that we just talked about, which is dangerous in itself, because then we're more likely to continue to have those biases. Okay, so kind of interesting. And all of these biases, I'm sure, kind of make sense, or you've heard about them before, but it's really important that you're able to like match the names with different examples or what they are. Okay. So a lot of times we're just kind of being an intuitive thinker, which is okay. But ideally, we want to be a scientific reasoner to avoid the biases. And instead of just basing our information on intuition, what sounds right, what makes sense, what makes us feel better about ourselves, we should base our information, on real scientific research that has been done and controls for confounds, has these control groups, right? It's controlling for all the things that science is supposed to. Okay, researchers do create comparison groups and look at all the data. At least they're supposed to, right? A good scientist does. So it's best if we don't just be an intuitive thinker, but try our best to be a scientific reasoner, especially if we are performing some sort of scientific research. It's easy to be biased even if we're trying to perform science. But a good scientist looks at all the data, collects all the evidence, and not jumps to conclusions, forms conclusions based on that. Okay. Which leads us to trusting authorities. So your book talks about this a little bit, but you should not necessarily trust someone just because they're a scientist, right? Ideally, all scientists are good scientists, but that's not always the case. And a lot of non-scientific people, just intuitive thinkers, maybe they're famous and have a platform and talk about something. They have a really good story, so you're wanting to believe them. Try to avoid that, right? You shouldn't trust all authorities just because they're authorities, even if they are scientists. So, for example, this is Jenny McCarthy. She's the actress. She is an anti-vaxxers. She thinks that giving childhood vaccines later in life than is typically done would prevent autism disorders. So not necessarily anti-vaxxer, but whoops. She thinks we should not give vaccines when children are young. We should wait till they're older, to give vaccines, just based on her own personal experience, I suppose. And this is Dr. Paul Offit, who's a physician scientist. He's reviewed a lot of research, conducted scientific research on childhood vaccines, and says there's no link between a vaccination and autism, regardless of the age, and that studies show that they are effective in saving lives. So both of these people consider themselves authorities on the topic. In this case, Dr. Paul seems to be a more well-rounded scientific authority, whereas Jenny McCarthy might not know all the facts. But even so, you should always question authority. So just because a scientist says something doesn't necessarily mean it's true. Just because your professor says something doesn't necessarily mean it's true. No matter who the authority is, don't just take what they say and say, oh, they know what they're talking about. I'll believe that. I encourage everyone to do their own research, especially on issues that are important to you, right? Just don't go to one news source, read an article that one guy wrote and say, oh, yes, all of this is good. You should take a look at all the evidence, and make decisions for yourself. Obviously, if you're reading something written by an authority, it's a good place to get information, but don't just read one little article and call yourself good, okay? A lot of times people who are scientific authorities publish their work. This is you're going to talk about a lot more in lab, but there are some questions on your quiz this week about this stuff, so I'm going to make sure that you guys are at least exposed to it, so you can get these questions. So obviously, journal articles is psychology's most important source of information, peer-reviewed. Scientists conduct research, go through an extensive peer review process, and then can publish their work in these journal articles. Right, so there's a few different types of journal articles. Empirical journal articles are like your typical one that you would think about. So they report the method and results for research studies that are reported for the first time. So they do their own study and go through the abstract, introduction, the whole research kit and caboodle. But we also have review articles, and there's not like actual research being done. Review journal articles just take all of the information on the topic and bunch them together. Whoever writes that article reads all of the information out there, and creates like a summary of that information, right? So it's not like new empirical research. It's just compiling all the information we already have on the topic into one source. Okay, so you can qualitatively summarize, or you can quantitatively summarize. Qualitative is just using like descriptors. Quantitative is numbers. And a quantitative approach in a review article is called a meta-analysis. So that's where they use statistics and combine all the data. So not just looking at general trends or, they found the same things, but looking at that data, compiling it to get real statistical numbers. Okay, and that's, again, a meta-analysis. There's other scientific sources as well. So some books. We have edited books. An edited book, each chapter is written by a different author, but they all have a similar theme. So these are also peer-reviewed, but just not any more extensively than a journal article. And then you have full length books. It's not as common for psychologists to publish, but other disciplines, a lot of times people will write, their own books. But those are other ways to find some scientific sources. Places to look, again, in lab. You guys are going to actually be going through this, so I'm not going to go too in depth. But Psycinfo is a great source. Very good. Great. Maintained by the APA, or American Psychological Association. And it's specifically for psych information. So that's why it's good for this class and any other psych classes you may be taking. But also you can get information from Google Scholar as well. There's some other places as well, but you'll talk about this more in lab. Okay? Again, you're going to go in depth of all this in lab, but I'll just talk about it quick. Components of an empirical journal article, right? So a journal article that there's actual empirical research being done. We have an abstract, which is a summary of the article, just kind of tells you what it's about. An introduction explains like the topic, some background information, states the goals and the hypothesis for the research. Your method section explains exactly what's being done in the study. So if someone wants to replicate it, someone can read the method section and, step by step, it tells you what they did, how many participants, how they grouped them, blah, blah, blah. Results describe like statistical tests that were used and like the number data, which sometimes doesn't really tell you much. It just, numbers and statistics. But in the discussion, you have a summary of the significant results. So if there's something in the results section that's significant, the discussion section will dive into that, try to explain it, come up with maybe possible alternative explanations, talk about any confounds, you know, future research directions, all that important stuff. And then obviously references. So especially in the introduction, if we're giving background information on the topic, we need to include references. So at the very end, we're including references of all the articles, information that was cited in the research. Okay, and again, lab. Reading with a purpose. I'm just going to skip this because you are lab again, and none of this is on the quiz, so you'll be okay. And then obviously you can get information from a number of places. We've already discussed that. If we're reading information, obviously you can also go to a bookshelf, find books that have lots of information on a topic you might be interested in. But this is not necessarily the best way if you're trying to be scientific about it, because we don't really know who wrote that book, right? We don't know if it was peer-reviewed. It could have been some psycho that, has this crazy belief and just wrote a book and it got it published. It has a pretty cover, so you picked it up. But it's not necessarily scientific, not peer-reviewed. And books on the retail bookshelf are written for a more general audience, right? If they're good books, they will have a reference section. And in the book, if it's informational, obviously not like a story time book, but if it's informational, they will cite their sources. So if they give you any statistic or information, they should cite where they got the information from. If not, then it's probably not a good sciencey book. Wikis, so Wikipedia, etc. Again, you should already know this. Not necessarily a good research source. Maybe good to get some like general information, get your brain thinking. But once you get kind of an idea of what's going on in that topic, you should do some actual research, because Wikipedia is not always reliable. And then popular press, journalism. Obviously, journalists take information, water it down, a lot of times exaggerate, have clickbait titles, whatever it may be. So popular press, although it's good to get some scientific information out to the masses, don't always have reliable information. So for these, definitely be weary. Yeah. Okay, so that was chapter 2. There was an activity on EduCat, taken from the learning actively portion, at the end of the chapter, plus a few other things in there. But if you have questions, let me know. Okay, bye.